Hi guys, welcome to another video for biology. In this video we are continuing our discussion on aquatic ecosystems. In the last video we discussed freshwater and how much fresh water is actually on the planet, rivers and streams. And now we're moving a little bit more downstream into lakes and ponds. So if you remember this image here, this figure that's in your text, so we started off with the headwater flowing down the river. Remember, the water flows fast, it's cold water, so there's not a lot of nutrients. In fact, this type of water is called Eutrophic. So that's an Eutrophic body of water. Oglio meaning few, tropic meaning nourishing. So there's very few nourishing molecules there. So not a lot of life takes hold up in the mountains and the raging rivers. But then as you start going down, like we mentioned before, the water slows down, it warms up, and it picks up a little bit more nutrients. This we call the eutrophic water system. Eutrophic meaning mini, so the EU prefix. This is all Greek lettering or Greek prefix. So the EU, eutrophic, means mini, so that's a lot of nourishing molecules there. That's from sediment, from animals that live and die in the water, and they're as they decay, they release more nutrients. So more plant life, thus more animals will live there. And so what can happen sometimes as you're going downstream from the river, you can have areas where water can build up, and we call these bodies of water lakes and ponds. And we're going to spend a little bit of time talking about lakes and ponds in this lecture. So here we have an image that again is in your text on page 76. This is figure 22. We're taking a look at how the overturn of water in a body of water, a lake or a pond. Now ponds obviously are not as big as lakes. Ponds can come and go as the seasons change. Lakes, they're typically a little bit more permanent. Many of them have been around for thousands of years. There are man-made lakes too, but we're talking here about natural lakes, typically like ones that you find at the bottom of a mountain or maybe even in a mountain. And so the lower you go down into the mountain, again, the warmer the water is, the more nutrients. And so let's take a look at the top image here. You have summer stratification. That word stratification, remember, it means multi-layered. So it's multi-layered in terms of temperature. So the top layer of water will be a little bit warmer, and as you go down, it'll get less and less. You get less and less sunlight, less and less heat, so it gets colder. And what can happen in the spring and in the fall, you have a lot of overturn from the changing of the seasons, changing in pressure. So the water kind of gets swirled around, and what will happen is that the bottom water, the deeper water, the profundo water, which has a lot of nutrients because of decaying matter, animals that die off and sink to the bottom, plants that die off and sink to the bottom, a lot of nutrients get stuck at the bottom. And what will happen with this overturn is that these nutrients get mixed in with the other levels of water, providing more nourishment for plants and animals at the top layers. And so then you have winter stratification. And again, that word stratification meaning there's a multi-layered. And in this case, the layers occur because of ice buildup. If it's cold enough at the surface, the water at the surface will freeze. It can freeze anywhere from a couple of inches to a couple of feet. And what will happen is because ice is less dense than water, it'll float. It creates a nice little protective layer, like a little coat, if you will, a protective layer from the surface that's super cold to the water that's down below. So the water below the ice will actually be warmer, and it can still sustain life through winter months. So here we are. We have another figure from your text that we're looking at, and this helps to illustrate the different layers of water, pond water or lake water. So the first layer, where you have most of the sun hitting, where it's not as deep, it's the more shallow area. This is called the littoral zone. So littoral zone has more sun, so that means that organisms that are photosynthetic dependent can survive there. And as you have more photosynthetic plants, you can have amphibians and reptiles that will usually inhabit this layer. There's a lot of predators there too. And so as we're kind of moving out, so just to kind of imagine yourself walking out into a lake, and the littoral zone is the first layer that you go into, and then you're going to swim on the surface. That's the limnic zone. So you still have some sun that hits, and it's a little bit warmer water, and you'll have a lot of fish. And actually what brings the fish to the surface is the fact that we have, like I mentioned, photosynthetic organisms. You have photoplankton, so these little microorganisms that are dependent on sunlight. And they are actually responsible for up to 50% of the oxygen in our atmosphere. The old school thought was that the rainforests were like the lungs of the earth, and yes, they do play a big role, but as it turns out, these photosynthetic molecules in water, like lakes and especially the oceans, actually produce most of the oxygen that we breathe. So in any case, so this photosynthetic organisms, they thrive at this layer, at the limnic layer, because of the sunlight. So they take in carbon dioxide from the air and they excrete oxygen, and they just grow. And fish feed on these things, and then the fish grow. And so now, as you start, just imagine yourself again. You're swimming at the top layer, and then you're diving deep, and you want to touch the ground. Now you're getting into the profundal zone. You're getting into the colder water because there's less sun, there's less light, and you have bottom-dwelling organisms that live down there, like your crustaceans, your bivalves, catfish, and such. So this is called the profundal zone. Let me go back actually to the previous image here. So that's lake water and pond water that we're talking about. Now, one of the things that happens, now sometimes these lakes can be standing and they stay the way they are. Other times the lakes serve as a reservoir, as a stopping point for water, and it'll continue going downstream, and it continues to warm up, and it continues to pick up more sediment, more nutrients, and you reach an area called an estuary region or a delta. And these can form bogs, they can form swamp areas, and in these areas you have a lot of diversity of organisms. Remember we mentioned before that and just like 0.3% of our fresh water is where most of the organisms live. And again, it's due to the fact that the water is warmer and it has more nutrients and it's slow flowing. And so you can have, you start having larger organisms. It can sustain things like crocodiles. Think of the Florida swamps. Think of the Louisiana bayous. Not areas that you necessarily want to live in because of humidity and bugs and such, and crocodiles. But excellent for those organisms. And so as the water flows into these regions, they actually continue to push out sediment by the tons. Every year, tons of sediment, starting from the mountaintop all the way down to the estuary region. You'll have sediment being pushed out into the ocean. And at this point, this is where freshwater and saltwater meet. And this is actually where we're going to pick up the next video. So at this point, at our transitional regions, at a transitional aquatic ecosystem, here's where we're going to stop, at the wetlands, estuaries, swamps, bogs, and we'll pick up with marine ecosystems, and then we'll push out deeper into the ocean. All right, guys, thanks for listening and watching, and good luck in your study.